Hello everyone, today I will be presenting on magnesium peroxide and its use in bioremediation of groundwater. Groundwater is the water that is found underneath the Earth's surface as shown here. It supplies drinking water for about 51% of the US population. It's used for irrigation to grow crops, and it's needed in industrial purposes. So what is bioremediation? It's a process that's used to treat contaminated media, including water, soil, and subsurface material, by changing environmental conditions to stimulate growth of microorganisms and remove target pollutants. The problem is that groundwater gets contaminated due to gasoline, oil, road salts, and other chemical spills. The purpose of bioremediation is to remove these contaminants efficiently and without destroying any microbial environment. Magnesium peroxide is directly injected into groundwater, as shown in the picture here. When magnesium peroxide reacts with water, the chemical equation 1 represents the reaction. The hydrogen peroxide decomposes immediately to water and oxygen, as shown in equations 2 and 3. Most bioremediation processes involve oxidation reduction reactions like equation 3, where either an electron acceptor, commonly oxygen and iron, is added to stimulate oxidation of a reduced pollutant, or an electron donor. When reacting with iron, as shown in equation 4, it's important to remove as much iron from the reaction as possible because of iron's ability to catalyze the degradation of the peroxide. Also, magnesium peroxide reacts with water to form magnesium hydroxide, which can affect the yield. Magnesium peroxide is economic and efficient process used for bioremediation. So why magnesium peroxide? Well, it's an oxygen-releasing compound, has very low solubility in water, slowly decomposes to oxygen upon exposure to water, releases oxygen for several months as opposed to hydrogen peroxide. Reducing the size of solid magnesium peroxide to nanoscale increases contaminant removal rate. To prepare magnesium peroxide nanoparticles, 10 grams of magnesium chloride is dissolved in 100 milliliters of deionized water. 20 milliliters of hydrogen peroxide is added to the solution and stirred for an hour, and this can be described by chemical equation 5. Magnesium peroxide is converted into nanoparticle size by electrodecomposition. In a 250 milliliter beaker with stainless steel electrodes under 10 volts current, for 30 minutes, as shown in the figure above. The deposited nanoparticles were physically removed from the electrodes, washed with water, and dried at 60 degrees Celsius. And these are my references. Thank you.